This is section 10.2, and we're going to begin our study of conics. The parabola is the first one that we will look at, and the formal type definition says it's a collection of all points the same distance from a fixed point F as from a fixed line D. F is the focus, D is the directrix. So there are some handouts in the course that have parabola notes, ellipse notes, and hyperbola. It would be worthwhile to go ahead and print those so that you would have them for your work and certainly when you are testing. So this first chart is something that you'll see on those handouts. The equations of a parabola with the vertex at 0, 0, and the focus on an axis where A is greater than 0. So let's look here. A parabola, you're used to seeing y equals x squared. Those are these two right here where you're used to seeing something go this way or upside down. But we also have the y squared equals 4ax and negative. So this chart is really helpful to do your work. The vertex, you can see it's always 0, 0 in this one, but the focus changes, the directrix is different, the axis of symmetry is the same, but it opens differently. So the equation, your basic one, y squared equals 4ax, that is going to be this one where it opens to the right. And if you have that one, the directrix is x equals negative a, and the focus is a0. The focus is always inside the parabola. So here we have a comma 0. The same distance from here to the vertex is from here to the directrix. And this would be negative a because you're going the opposite direction. In this one, y squared equals negative 4ax, it opens left. So you've got a focus at negative a0 and the directrix at x equals a. So those have just flip-flopped. For x squared equals 4ay, that's that parabola you're used to seeing, and the focus is at 0 and a is up here on the y-axis, and the directrix is y equals negative a down here. And then the flip of that, if it's upside down, the focus is 0, negative a, and y equals a is the directrix. So you should have that chart. It will help you in your reference. You don't necessarily have to memorize all of it, but you want to understand the chart. You want to be able to use the chart. So let's look at a couple of examples. Analyze, find the vertex, directrix, and focus if you are given y squared equals 8x. Well, we know this is a positive number. So we go back here. We're on the first line. We don't look at anything else except this first line. So y squared equals 4ax. We know that 4a is the same as 8 because that's what's given. So 4a equals 8. A is 2. That's going to help you fill in. Remember the focus here, the focus is 2 comma 0. So we know A is 2, focus is 2 comma 0. The vertex is 0, 0. The directrix is x equals negative a, so negative 2. All right. Now, if you are graphing these by hand, which face-to-face, we may do that. So you understand where the directrix is, you know where the focus is, you know where the vertex is, but you really don't know how wide this is. And there are 2 points that connect through the focus, and that's called the latus rectum. And I just usually abbreviate it with LR. But you know that it goes through the focus. And so if x is 2, if you let x is 2, then if you plug in that, you've got y squared equals 8 times 2, y squared is 16, y is plus or minus 4. So the 2 points that you'll use for the latus rectum are 2, 4, and 2, negative 4. Then if you plot those, you have a really good sketch of where that parabola goes. So usually you will need to find those as well. All right, x squared equals negative 12i. that follows the form x squared equals negative 4ay. If we go back up here, right here, last line, that's the one we're going to use. We're going to know that our focus is 0, negative a, and our directrix is y equals a. So let's go here. So we know that negative 4a is equal to negative 12. So a is 3. So the focus is 0, negative a. So 0, negative 3. The directrix is y equals 3. Then we're going to substitute the negative 3 in here in this equation. So x squared is negative 12 times negative 3. X squared is 36. X is plus or minus 6. So you have 6, negative 3, negative 6, negative 3. So when we graph it, we have the vertex at 0, 0. We know y is 3. We know the focus is at 0, negative 3. And then we have negative 6, negative 3, and positive 6, negative 3. And then we can graph. Find the equation. Now this time we're not given the equation. We're supposed to find it with a focus at 0, 4 and a directrix y equals negative 4. So this tells me A is 4. So if we go back here, where y squared equals 4ax. So we're at that one and it's going to open right. I don't have that one graphed, but x squared equals 4ay, and we'll plug in the 4. So x squared equals 4 times 4. We get x squared equals 16y. And all it asked was actually to find the equation. But you could graph that as well. Find the equation. If the vertex is 0, 0, the axis of symmetry is x-axis, and it contains the point negative 1/2, 2. Negative 1/2, 2. So if it contains that point, let's think about that. If we go to y, let's see, we know that, let's think about where that point, we know that this is a point on the parabola. So if we were at negative 1/2 and up 2, that means that's on the parabola and the vertex is here. So this parabola has got to open left. And the one that says opens left is y squared equals negative 4ax. So once we hone in on that, we can plug in the negative 1/2 for x and the 2 for y. So 2 squared is negative 4a times negative 1/2. That gives us positive 2. So 4 equals 2a. That means 2 is a. And when we plug in the 2 right here, we get y squared is negative 8x. That's the equation. And we could graph it from that point. All right. The other sheet that you will have in your handouts is when your vertex is not at 0, 0, but rather at a point h comma k. And that's much more confusing. I get that. But you're following the same kind of information. Just follow these equations here that will help you plug in what you need. So on the top one, you are opening right, and here is your vertex, and the focus is at h plus a, whatever that number is, comma, k part of the center. The directrix is x equals h minus a. And so all of that, you'll start doing it, and we'll see some in the problems. But if you follow these equations here, you should be okay. So on this, I just want to show you real quickly, and then we'll see what we've got in the problems. But if you had a vertex at negative 2 comma 3, so h is negative 2, k is 3, and a focus at 0, 3. Well, y minus k squared equals 4a times x minus h. The k that we plug it in just like that. And here we've got x minus h, that's x minus a negative 2. and we had to figure out what A was. Well, H plus A equals 0. The focus here is 0. So -2 plus A is 0. That means A must be 2. That number gets plugged right there. So here is our equation. So let's go look at our problems. All right, number 1. The graph of y equals x minus 3 squared minus 5 has a vertex of. So remember the vertex, you change the sign on this one when you pull it out. So that's 3, -5. And an x-axis of symmetry would be x equals 3, because it's always x equals that if it's that one. It's x equals that number. All right, select this. What form is the collection of all points in the plane? And there's that definition that we had, and we know that's a parabola, and the line that goes through the focus and is perpendicular to the directrix is called the axis of symmetry. The line segment joining the 2 points A, 2A, and A, -2A is called and remember that's the lattice rectum that goes through the focus. All right. In this one, if A is 4, then the coordinates of the focus are. On this one, you're going to add, if A is 4 and the vertex is at 2, the y part is at 2, you're going to add 4 to 2, and so that would be 3, 6. That would give you the focus. And you're using that chart to do that. Okay. Find the equation of the parabola described below, find the 2 points that define it, and graph the equation. So the equation of the parabola, focus at 4, 0, and a vertex at 0, 0. So we know that A is 4. We have y squared equals 4ax, so that becomes 16x. And then if you let x equal 4, if x is 4, remember that's the focus, you have y squared equals 16 times 4, y squared is 64, y is plus or minus 8. The 2 points that define the lattice rectum are then 4, 8, and 4, -8. And you would graph that using those 3 points, the vertex at 0, 0, and those 2 points. You will be graphing it online, and I'll see if I can get something to show you that in just a moment. Number 6, find the equation, same idea, but our focus is the y-axis going through the y, so we know we've got x squared equals 4ay, and if a is 3, there's our a, then it's 4 times 3, so we have x squared equals 12y. That is the equation. And then we substitute the 3 in there. X squared equals 12 times 3. X squared is 36, so x is plus or minus 6. And your 2 lattice rectum points are here, 6, 3, and -6, 3. So that's the same kind of thing, only with your y-axis being your axis of symmetry. Number 7, find the equation. So the vertex is now at 3, -4, and the focus is at 3, -6. So what I pull from that originally, H is 3, K is -4. The vertex and the focus are both going to lie on x equals 3. The distance between 3, -4 and 3, -6 is 2. Where did we get the -6? Right here, right here. You've got a focus at 3, -6. You got the vertex at -4. So the distance between those two is 2. That means your A is 2. Since the focus is below the x-axis, the parabola is going to open down, because remember the focus has to be inside the parabola. So it's going to open down. This is the form, the basic form. we're going to plug in what we've got. X minus 3 squared, because the vertex part, that was 3, equals negative 4 times 2, we figured out what A was, times y minus a negative 4. So ultimately, this is our equation that goes right here. To find the points of the lattice rectum, let y equal negative 6 and solve for x. So if I let, because here's your focus, remember, there's your focus. So if I let y equal negative 6, I've got x minus 3 squared equals negative 8 times negative 6 plus 4. That becomes negative 2. Negative 8 times negative 2 is 16. So now I've got this equation and I can take the square root of both sides. Over here I get x minus 3. Over here I have plus or minus 4. So I have two things. X is 3 plus 4 or x is 3 minus 4. So those are my two x values that are going to go with the y equals negative 6. And that's what goes right here. 7 negative 6 and negative 1 negative 6. Number 8, write an equation for the parabola shown to the right. So we know that this is opening left, so according to our chart, we'll go look at our chart. Here's our vertex at 3, 1, and it opens left. So your form is this one. You go back to that original chart that we talked about when the vertex was not at 0, 0. Now, if we plug in what we have, we've got y minus 1 squared equals negative 4 times a times x minus 3. Now we'll use the point that's given, and we have one point here, 2, 0. So we'll plug in 2 for x and y for 0. So 0 minus 1 squared is negative 4a times 2 minus 3. We clean that all up, and we end up with 4a equals 1. And we'll substitute 1 in for 4a in this here. We have a negative 1 because 4a is 1. So the negative's there, but we'll substitute in, and so we have y minus 1 squared equals negative x minus 3. And we got all that from looking at our equation and knowing what to do with our chart. Number 9 is the same thing. This one opens to the right. The vertex is at negative 6, 0. So here is your form. We're going to plug in what we know. Y minus 0 squared equals 4a times x minus a negative 6. Cleaning that up, we get this. We're going to find a by using the point 0, 12. So I plug in 12 for y and 0 for x, and I get 144 equals 4a times 6. If you divide the 6 over there, you get 24 is 4a. So I'm going to take this value, which is what 4a is, and I'm going to put it in. So I have y squared equals 24 times x plus 6. Okay. Number 10, the last one is a word problem, which is our favorite. Let's go see about that. All right, a bridge is built in the shape of a parabolic arch. The bridge has a span of s equals 180 feet and a maximum height of h equals 20. Choose a suitable rectangular coordinate system and find the height of the arch at distances of 10, 30, and 50 feet from the center. So the form, it's opening down. We've got x squared equals negative 4a y minus k. The vertex is at 0, 20. That's that point up there. The focus is at 0 and 20 minus a. We've got to find out what a is. So solve for 4a using the point 90, 0. We're going to use this point right here. So if I substitute 90 for x, I've got 90 squared equals negative 4a times 0, there's my y, minus 20. All right, so 8100 equals negative 4a times negative 20, and negative 20, that negative and that negative will cancel each other out. So we have 4a times 20. Then we'll divide by 20 and we get 405 is 4a. So instead of 4a here, we're going to, where was it? In this one, instead of 4a, we're going to put in our 405. And we had a negative there to start with, so we'll have negative 405 times y minus 20. That's our basic form. So then we need to solve for y, because we are trying to find different heights here. So we are going to divide by the negative 405. So now we have this, and then we're going to add 20. So this is what y equals, okay? And they said figure out the height when x is 10, x is 30, x is 50. Then it's just calculator. You're putting 10 in for x, 10 squared over negative 405 plus 20. That's going to give you 19.75. If you're putting in 30, you get this value. 50, you get this value. And it does say to round to 2 decimal places. So those are the 3 answers. You didn't even have to put in this other stuff, but we had to do that to be able to solve. So that's how you're going to do number 10. So I've pulled up number 5 in your homework, a question like number 5, where we were given the focus and the vertex, and I went ahead and figured out the equation of the vertex like we did in number 5 and the 2 points that made the lattice rectum. So let's see what we have to do to graph it on the computer. So if I click there, and I know that I am going to do a parabola that opens, ours is opening to the left, so we're going to do a sideways one, and the vertex is at 0, 0, and our points are negative 8, 16, so negative 8 and up to 16, and I don't know if that did it. Let's see. Okay, so as long as you have one of the points, it looks like it will be okay. So we figure out this like we did, but when I was showing you in the video, I was not on the computer question, so I knew it would be a little different in what to do. So figure out these, plot the vertex and at least one of these, and save it, and you should be fine. So I think that that will get you through to 10.2.